Our objective in this lesson is to illustrate combined variation. Let's have a quick review of our previous lessons. Tell whether the following is a direct variation, inverse variation, or joint variation. Number 1, y is equal to 5x. This is an example of direct variation. Number 2, y is equal to x over 5. This is an example of, once again, direct variation. Number 3, xy is equal to 15. This is an example of inverse variation. And last one, we have area is equal to 1/2 base times height. This is an example of joint variation. Today's discussion will focus on combined variation. Combined variation involves more than one type of variation, meaning it is a combination of direct or joint variation and inverse variation. Suppose we have the statement W varies directly as X and Y and inversely as Z. If we are going to convert this statement into an equation, this will become W equals KXY over Z. Varies directly as X and Y and inversely as Z. Now, to solve for K here, we're going to multiply W and Z and then divide by the product of X and Y. So K will be equal to WZ over XY. Once again, K here is our constant of variation or proportionality constant. Remember that K cannot be equal to 0. Are you aware of Isaac Newton's law of universal gravitation? It states that every object attracts every other object with a force along the line of centers between them. This force of gravitational attraction is directly proportional to the product of masses of both objects and inversely proportional to the square of the distance between their centers. This is a perfect example of combined variation. To convert this statement into an equation, this will become F is equal to G times m sub 1 times m sub 2 all over r is squared. F here is the gravitational force. M sub 1 and m sub 2 are the masses of two objects. R here is the distance between their centers. And G here that serves our K is the universal gravitational constant, which is equal to 6.67 times 10 raised to negative 11 Newton meter squared over kilogram squared. Let us write some more equation of combined variation. The time t required to travel is directly proportional to the distance d, so that would be kd, and inversely proportional to the speed, so that would be over s. Number 2, m varies jointly as p and square of q, that would be q squared, and inversely as r, all over r. Number 3, the electrical resistance R of a wire varies directly as its length, so we have KL, and inversely as the square of its diameter, so all over d squared. Now let us solve. If L varies directly as m and inversely as the square of n, and L is equal to 4, when m is equal to 8 and n is equal to 4, find L when n is 6 and m is 18. So first, let us convert this statement into an equation. So we have L varies directly as m, km, and inversely as the square of n squared. Now let us substitute 4 for L, 8 for m, and 4 again for n. 4 squared is equal to 16. By cross multiplication, 4 times 16 is 64. To solve for k here, we're going to divide both sides by 8. This 8 here will cancel out, and 64 divided by 8 is 8. So k is equal to 8. Now let us solve for the value of L when N is 6 and M is 18. Let us rewrite again our equation. We now know the value of K, and that is 8. Let us substitute 6 for N and 18 for M. 6 squared is 36, while 8 times 18 is 144. And 144 divided by 36 is equal to 4. So L is equal to 4. Let us try this. If I varies jointly as P and Q and inversely as the square root of R, let us convert this one first into an equation. So we have I varies jointly as P and Q and inversely as the square root of R divided by the square root of R. Now let us substitute 15 for I, 5 for P, 6 for Q, and 16 for R. So we have the square root of 16 is equal to 4. By cross multiplication, 15 times 4 is 60, while 5 times 6 here is equal to 30. To solve for K, let us divide both sides by 30. So this 2 will cancel out, and 60 divided by 30 is equal to 2. Now let us write once again our equation. Let us substitute the value of K, which is 2, P, which is 8, 3 for our Q, and 4 for our R. The square root of 4 is 2. So we can cancel this 2 here. And 8 times 3 is 24. So I is equal to 24. Let us do extra challenge. In baseball, a major league pitcher is judged on the basis of his earned run average, denoted by A, which varies directly as the number of earned runs, denoted by R, and inversely as the number of innings, denoted by I, pitch. We are going to solve the following. Let's start with letter A. Express the statement as a formula. Our formula will be A varies directly as R, so that would be KR, and inversely as I, divided by I. Let's solve letter B. If a pitcher has an earned run average of 3.7 after pitching 95 innings and allowing 39 earned runs, what is the value of K? Let us recall our answer in letter A, our formula. Now let us substitute 3.7 for our A, that is the average. 95 innings, 95 would be the I. And 39 earned runs, 39 would be our R. So we have, by cross multiplication, 3.7 times 95 is equal to K times 39. We're going to solve for the value of K, so we're going to divide both sides by 39. This 39 here will cancel out. 3.7 times 95 is 351.5. Divided by 39 is equal to 9.01, or round off to 9. Let us answer letter C. What is the earned run average of a pitcher who gave up 85 earned runs in 400 innings? Again, let us recall our answer in letter A, the formula, as well as our answer in letter B, the value of K. Now let us substitute 9 for our K, and then 85 for our R, and 400 for I. 9 times 85 is 795. Divided by 400 is 1.91. A little bit of trivia about baseball. Ed Walsh has an average of 1.82, which is the lowest of any pitcher in the history. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. First, we're going to convert this statement into a formula. So A varies jointly as the square root of B, and the absolute value of D and inversely proportional to the cube of c. So that would be a is equal. Varies jointly as the square root of b. So we have a square root of b and absolute value of d. And inversely proportional to the cube of c divided by c cubed. Now let us substitute 3 for our A, 25 for our B, negative 4 for D, and 2 for our C to solve for the value of K. Square root of 25 is 5. The absolute value of negative 4 is 4. And 2 cubed, 2 times 2 times 2 is equal to 8. Let's do cross multiplication. 3 times 8 is 24, while 5 times 4 is 20. To solve for k, let us divide both sides by 20. So this will cancel out. 24 and 20 are both divisible by 4. 24 divided by 4 is 6, and 20 divided by 4 is 5. Therefore, our k is equal to 6 over 5. Gets? Our next lesson is all about exponents.